In this lesson, we're going to look at combinations, and this is going to be part one of the lesson on combinations. Now, remember in the previous three lessons or so, we looked at permutations. Now, remember with permutations, the order mattered. So let's look at combinations. Now, to begin with combinations, let's look at this scenario. Okay, so the following 10 artists were, or musicians, were listed by USA Today in the group of best musicians of the 1980s. And so you have Michael Jackson, Prince, Hall & Oates, Whitney Houston, David Bowie, Phil Collins, The Police, Billy Joel, Rolling Stones, and Bruce Springsteen. Now there were many others, but those were some of the best. All right, now suppose you ask three friends to list four of the above musicians that he or she likes the best. And so let's say friend one listed Prince, Billy Joel, David Bowie, and Springsteen. Okay, and let's suppose in trying to get this um, situated. So let me see something for a moment. Okay, so the view's a little bit better with this. All right, so I had to focus it a little. All right, and let's suppose that friend two named Bowie, Prince, Springsteen, Billy Joel. And then friend three listed Hall & Oates, Michael Jackson, The Police, and Rolling Stones. Okay? Now, I want you to notice something. If you look at friend one and friend two, um, they both listed the same individuals, didn't they? Prince is listed first here. Um, and second here. Billy Joel is listed here. David Bowie is listed here, and Springsteen's here. So your friend one and friend two, like the same individuals, but they're not in the same order, right? But does it matter? Does the fact that the order here matters? Because all you asked him to do is just list four of the above musicians he or she likes the best. You didn't ask that person to rank them. You didn't ask that person to put them in any specific order. You just said of those listed, what are your best, right? Okay. So what I want you to notice is that friend one and two, even though even though they listed the same individuals, the items were taken without regard to order. Okay, so the order did not matter. Order did not matter. Okay, so when you talked about this, when you asked your friends to state the four um, artists listed here that they like the best, you didn't tell them to rank them at all. Okay, so basically what I'm saying is that these two lists here are the same, aren't they? Those are the same order, the same listing. It's in a different order, but the order did not matter. But those are the same. It's the same list. Okay. So so this is not a permutation problem. This is not a permutation problem. Okay, so keep that in mind. So the order did not matter here. All right, so that's not a permutation problem. Okay. All right, so um, let's go ahead then and talk about, well, what kind of problem is this, right? So let's talk about what kind of problem is this. So this is going to be the idea of a combination problem. Okay, so we're going to talk about combinations. Now, before we talk about combinations, let's look at this situation. Suppose, well, consider the letters A, B, C, and D. Okay, consider the letters A, B, C, and D. Now, if I asked you to tell me the number of permutations, so the order would matter if I say the number of permutations. So if I asked you, though, to tell me the number of permutations of these four letters taken three at a time, you would say the permutations of the number of permutations of four taken three at a time will be 4 factorial divided by 4 minus 3 factorial, right? which is 4 factorial divided by 1 factorial, which is 4 times 3 times 2 times 1 divided by 1, which is 24. Y'all agree? And so here are the 24 listings right here. So for A, B, C, and D, taking 3 at a time, you have ABC, you have ACB, you have BAC, you have BCA, and so on. And over here, and I want you to notice that all these, do y'all see that all these letters right here are the same, A, B, and C, just in different orders, right? Okay, so these are permutations. So in permutations, the order mattered. Okay, so notice these letters are all ABDs. All these letters consist of A, B, and D. All right, and so there are the letters, the list, and then over here you have all these consist of the letters A, C, and D in different orders, and this consists of the letters B, C, and D in different orders. So there are 24 altogether. Y'all agree? Okay, so if order mattered, these would all be your permutation. There'll be 26 of them. Okay? All right. Now, because the order of these items makes no difference in determining combinations, remember in combinations, we now know that combinations order does not matter. Okay? Order does not matter. All right, order does not matter in combinations. Okay, so because the order of the items makes no difference in determining combinations, each of the 6 permutations represent, each column of the 6 permutations represents one combination. So for example, do y'all see that all of these represents the same combination as ABC? So ABC is ACB is the same as ABC. Order does not matter. Okay, if order doesn't matter, is this the same as this? Yes. If order does not matter, is ACB the same as ABC? Yes. Just like friend 1's list is the same as friend's 2 list. You see that? Friend's 1 list is the same as friend 2's list. Same individuals, same artists, same musicians, but the order is listed differently, but that doesn't matter. It's still the same list. The order, it's in a different order, but that doesn't matter. It's still the same list. Okay, all of these. So if I look at this one, isn't this right here the same as ABD? So if I put ABD first, is all of these the same as this one if order does not matter? Yeah. It's all the same. It all has the same letters. Over here, if I put ACD first, would all of these be the same? Same listing if order did not matter? Yes, it would all be the same. And over here, if I put BCD first, if I just say this, BCD, would all of these be the same as BCD? Is this string right here of characters BDC the same as BCD? If order did not matter, yep, it would be. They are the same. So if order does not matter, then there are 4 combinations, and those are your 4 combinations: ABC, ABD, ACD, and BCD. Those would be your 4 combinations. Okay? And so remember when we talked about permutations, if order did matter, permutations would say the number of permutations out of 4 elements taken 3 at a time. Okay, this would be combination. So the subscripts would be the same. So you'd say combinations of 4 taken 3 at a time. That's what you would say. All right. So if order does not matter, it's combination. If order mattered, it's permutation. Okay? All right, now I want to go and talk about, well, how do we come up with a formula for combination? We know how to come up with a formula for permutation, or we know what the formula is for permutation. The formula for permutation, remember, is this. It's n factorial over n minus r factorial, right? What is it for combination? That's what you're trying to figure out. Okay? So so this right here means the number of combinations of four things taken three at a time. That's what that means. The number of combinations of four things taken three at a time. All right, that's what that means. The number of four things taken three at a time, and in this case, it is 4. Okay, with 24 permutations, right here, we had 24 permutations, right? 24 permutations, so all these. So my permutations are 24. And only 4 combinations. So do you see that with permutations, there were 24 lists, right? And with combinations, there were 4, okay? Do y'all also see that if I take the number 4, if I take 4, and multiply it by 6, I get 24, right? Okay, so note, I'm getting somewhere, so just follow me. Note 4 times 6 is 24, right? Okay. All right. So notice this. So the number of permutations is 6 times the number of permutations is 6 times the number of combinations. Okay, so in this case, the number of permutations is 6 times the number of combinations, because there are 4 combinations. 4 times 6 is 24. Okay. All right. Okay. So we can find a formula for this. We can figure out intuitively, based on what we just talked about. Well, what would this be then, given this? Okay, given permutations. Okay. All right. So so do y'all also agree that 6 in terms of factorial, 6 in terms of factorial is 3 factorial? And you see this 3 right here? That comes from this right there. Okay? So 6 is 3 factorial, right? 3 factorial. So I can write this as this now. Okay, so listen carefully. So this right here, so do y'all agree that the number of permutations of 4 items taken 3 at a time is 6 times the number of combinations taken of 4 items taken 3 at a time? So this is 4. 4 times 6 is 24, right? And so if I want to get this right here, by itself, I'm going to divide both sides by 6. So I get C, the number of combinations of 4 items taken 3 at a time, is the number of permutations of 4 items taken 3 at a time divided by 6, which is 3 factorial. 6 is 3 factorial. So divided both sides by 6. So this is going to be this divided by 6, or 3 factorial. Okay? All right. Now, notice that in our formula, this right here, I'm going to go back and write it. So this right here is number of combinations of n items taken R at a time, right? Okay? So in this particular example, R is 3. Okay? So based on this, that's going to be, I'm going to write this. I'm getting to the formula. So this whole thing is trying to get you to the formula. So right here, what I have is this. So the number of combinations of n items taken R at a time will equal the number of permutations of n items taken R at a time divided by R. Remember, this represents R, divided by R factorial. Okay, so that's going to be n factorial. That's right here. N factorial divided by n minus R factorial divided by R factorial. All right, now listen carefully. You got to remember something from a previous course. When you have a fraction divided by a fraction, you change this division to multiplication. So that's going to equal the top fraction, n factorial over n minus r factorial, times the reciprocal of the bottom fraction. So the reciprocal of r factorial is 1 over r factorial. And so now writing this as one fraction, n factorial times 1 is n factorial, and then this times this is just n minus r factorial times r factorial. And there's your formula. There's your formula for combinations of n items taken r at a time. All right, so that was a lot of discussion on trying to get you to understand where that formula came from. So we know that this part is permutations, right? So if it divide by r factorial, then that gives me the combination formula. But you got to understand, well, where did that r factorial come from? And that's this idea here, where we're trying to get where the number of permutations would be some factor times the number of combinations. Okay. So there's your formula. So we know two formulas now. Okay. So we know more than two formulas with this chapter, but in terms of permutations, we know this. The number of permutation of n items taken r at a time is n factorial divided by n minus r factorial. And the number of combinations of n items taken r at a time is n factorial divided by n minus r factorial times r factorial. Okay. Now, do you also see that given the same numbers for r and n, that this will be more than this? Okay. So remember how in our example, the number of combinations here was 4, the number of permutations was 6. Okay. Because you're dividing by a number here, so it makes it smaller. You're dividing this, see this right here is this, and you're dividing it by another factor, so it's going to make that smaller. Okay. Now, let's look at some examples. And now we need your calculator. So go ahead and take your calculator out. So on your calculator, well, actually, let's do this first. Let's do this by hand. I want you to do this by hand. So by hand, let's suppose no calculator. I want you to think about this for a moment before using the calculator. Okay? So no calculator. Suppose I want to find, number one, the number of combinations of, let's say, 7 items taken 6 at a time. Okay? All right, now I know this. I know that the formula is right here. So it's 7 factorial divided by 7 minus 6 factorial times 6 factorial, right? That's what that is. Well, 7 minus 6 factorial is 1 factorial. So 7 factorial divided by 1 factorial times 6 factorial. So that's 1. We know that. So that becomes 7 factorial over 6 factorial, right? So that becomes 7 times 6 factorial over 6 factorial. The 6 is divided out, so what's the answer? 7. Okay? All right, let's look at number 2. Number 2, without using the calculator, let's think about that. Number 2, let's suppose we had number of combinations of, let's say, 10 items taken, let's say, 8 at a time. Okay? So using our formula, that's going to be 10 factorial divided by 10 minus 8 factorial times 8 factorial. Y'all agree? Okay, so let's simplify this part. So 10 minus 8 is 2. So I get 10 factorial divided by 2 factorial times 8 factorial, right? All right, let's see how we're going to deal with this. Okay, what I would do first is this. Okay, so I would see how this number right here is bigger than this number. So I would go ahead and rewrite this right here, the 10 factorial, as 10 times 9 times 8 factorial. Okay, and I'm going to go ahead and rewrite this like this for right now. Just go ahead and do that. Now the 8 factorials divide out, and so you have this now. You have 10 times 9 over 2 times 1. Y'all agree? And then let's reduce. So I'm going to go ahead and rewrite this over. 2 into 2 is 1, 2 into 10 is 5, so I get 45. So that's your answer, 45. Okay, so the number of combinations of 10 items taken 8 at a time is 45. Okay, so that's where order does not matter. All right, number 3. So let's suppose in number 3 we had this. In 3, let's suppose I had the number of combinations of 9 items taken 1 at a time. Number of combinations of 9 items taken 1 at a time. Well, by definition, that's going to be 9 factorial divided by 9 minus 1 factorial times 1 factorial, right? So 9 minus 1 times 1 factorial. So remember that the formula is n factorial over n minus r factorial times r factorial. So in this case, n is 9, r is 1. So you're just substituting. Okay, now this right here is 9 minus 1 is 8, so that becomes 9 factorial over 8 factorial. Now you all know that 1 factorial is 1, right? So I'm not even going to worry about it. That's just 1 right there. Okay, so all I have is this. So now I'm going to write this as 9. Think about how you can make it easier on yourself. Do you want to go all the way to 1? 9 times 8 times 7 times 6? No. You know that this is 8 factorial, right? So at some point, when you rewrite the numerator, you're going to get that 8 factorial. And in fact, you get it now. And then reduce. They divide out, so you're left with 9. Okay? Number 4, let's suppose you had the number of combinations of 8 items taken 8 at a time. The number of combinations of 8 items taken 8 at a time. All right, well, that's going to be 8 factorial. Remember, this is your n, this is your r. So that's going to be 8 factorial divided by 8 minus 8 factorial times r factorial, and r is 8, so that's 8 factorial. Well, 8 minus 8 is 0, right? So that's 8 factorial divided by 0 factorial times 8 factorial. But what is 0 factorial? 0 factorial is 1. What's 1 times 8 factorial? Well, 1, see, this is 1 right here. 1 times 8 factorial is 8 factorial. But what is 8 factorial divided by itself? That's just 1. All right. So basically what you're going to see is that when you're taking combinations and n and r are the same, it's always going to be 1. You go through the process, you're going to notice, hey, the numerator and the denominator will be the same. So it's just 1. All right, now let's look at the calculator. Take your calculator. I'm going to do a few examples there. So I'm going to look at the calculator. So suppose on the calculator I had this. I had number of combinations of 12 items taken 8 at a time, let's say. All right, so on your calculator, let's see what that is. So you can do it just like you did permutations. So you're going to say 12, go to probability. All right, now remember you want combinations, right? That's this one. So you got to move your arrow right here, your right arrow. See how it's underlined now? Press equal, and now press 8, and then press equal, and you get 495. 495, okay? All right, number 6, suppose you had the number of combinations of 24 taken, let's say, 6 at a time. Number 24 taken 6 at a time. All right, so use your calculator. You're going to say 24, probability. Then you're going to move your arrow, okay, to combination formula. Press equal. You want 6, press equal. You get 134,596. So there's 134,596 ways to make a list of 6 items from 24, where order does not matter. Order does not matter. Okay? If this was a permutation, would the answer be more or less than this? It'll be more. It'll be more because order does matter in that case. All right, number 7, suppose you had this. All right, now you have the number of combinations of, let's say, 12 items taken 10 at a time divided by the number of combinations of, let's say, 6 items taken 2 at a time. Okay? All right, so let's see what that is. All right. Now, hopefully it'll come out nice because I made this up. So it may not. All right. So let's see. So we have so we have 12. Let's go to the numerator first. So that's 12. Probability, okay, 10 divided by, and then 6 probability, move the arrow, I mean yeah, I guess press your arrow, and then 2, and then press equal, you get 4.4, 4.4. All right, so I kind of, so just leave it like that, that's fine. Normally though, we're gonna, when we do these, it'll be a whole number. I just made this up, so it's 4.4, right? Just make sure you get 4.4. It's really a, in this case, it would really be some number divided by some number. So it would be 4 4/10. If you were to reduce this, that would be 44 over 10, which is 22 over 5. That's what you would get up here, 22 over 5. All right. Okay, so let's look at another one. So let's suppose I had this, number 8. Number 8, let's suppose I had the number combinations of 7 taking 3 at a time divided by the number combinations of 5 taking 4 at a time. Let's see what that is. So do it again. Use your calculator. Just do one more like this with a fraction. So 7 probability, move the arrow, and then number 3, divide, oops. Okay, let's do it again. Well, that's okay. It's 35. Then I'm just say divide. Okay, divide, and then 5 probability. Make sure you underline combinations. Press equal, and then 4. Press equal. You get 7. So make sure you all got 7. Okay, that's supposed to be 7. Okay, number 9. Let's look at this. Suppose I had the number of combinations of 10 items taken 3 at a time divided by the number of combinations of 6 items taken 4 at a time. Subtract 46 factorial divided by 44 factorial. All right, so it's not that bad. Just use your calculator. So you're going to say, let's do this fraction first. So you're going to say the numerator is going to be 10 probability. Move your arrow to combination formula. Press equal, then press 3. Then divide by this. So 6 PRB. Move your arrow, and then 4. Okay, and then you're going to subtract. So minus 46 factorial, PRB, go to factorial now. Remember where that is, right here. So you see 46 factorial divided by 44, and then go 1, factorial, press equal, and you get negative 2062. Okay, that's what you should get. Okay, and then number 10, let's suppose you had this, number 10. Suppose you had the number of combinations of 5 items taken 1 at a time times the number of combinations of 7 items taken 2 at a time divided by the number of combinations of 12 items taken 3 at a time. Okay? All right. So we may again end up with a decimal, but if you do, just go ahead and write as a fraction. Okay? Just write as a fraction. So let's look at this. So in the calculator, I'm going to say 5 PRB 1 times, see there's times, right? 7, go to probability, find, underline the combination, and then press equal, and then press 2. Divide, now you're dividing that by 12, probability. Okay, there we go. Press equal, and then 3, and then press equal. And I get this. Okay, so I get, all right, so I get this decimal that repeats. All right, so the best thing to do there is to convert that to a fraction. All right, so on your calculator, see right above PRB is this fraction to decimal, decimal to fraction thing. Okay, but it's blue, so go ahead and press second. And then PRB again, C, just press equal. You get 21 over 44. 21 over 44. All right? So just go back over what we did. All right? So basically, all right, so basically remember we got this, right? So once you get the decimal, this is what you do. You want to convert it back to a fraction, you do this. See, right above the probability button is fraction, decimal, decimal to fraction, okay? But it's blue, so you got to press your second. So press second, P or B. See how that looks like? Just press equal. Press equal. So you're converting that decimal to a fraction, and you get 21 over 44. All right, that's what that is. And if you want to convert it back to a decimal, you just say second P or B again, and so you got it back to a decimal. All right. Now, before I end this first part, let me just show you how to do this by hand to just verify that you got this. All right. So remember, all we did was use a calculator, but you could have done all this by hand. So let's look at this one right here. So this is by hand. So y'all agree that this up here means this. This means 5 factorial divided by 5 minus 1 factorial times 1 factorial, right? That is this. Y'all agree? Okay, times. Let's look at this. This would be 7 factorial over 7 minus 2 factorial times 2 factorial. Y'all agree with that? All of that, though, is being divided by this. So 12 factorial divided by 12 minus 3 factorial times 3 factorial. Okay? All right, let's simplify this part here. So that's going to equal. All right, that'll be 5 factorial over. Do y'all agree that 5 minus 1 is 4? So that's 4 factorial. This is 1 factorial, which is 1. So that's just 4 factorial. Y'all agree with that? Okay. Times over here. That's 7 factorial over this 7 minus 2 is 5 factorial times 2 factorial divided by. So all I'm doing is just simplifying the parentheses and other things as much as I can. Over here, that's 12 factorial over 12 minus 3 is 9, right? So that's 9 factorial times 3 factorial, right? Okay. So let's go ahead and simplify each of these as much as we can. So let's look at the first one. Do y'all agree that 5 factorial divided by 4 factorial is 5 times 4 factorial divided by 4 factorial, which is just 5. So that part right here is 5 times. Let's look at this one. 7 factorial divided by 5 factorial times 2 factorial. Do y'all agree? Do y'all agree that this is 7 times 6 times 5 factorial divided by 5 factorial and then 2 factorial is just 2, right? Well, the 5 factorials divide out. 2 goes into 2 one time, 2 goes into 6 3 times, and all you get here is 21. Yes or no? Okay. So that is 21. So this right here is nothing but 21. Let's go to the bottom one. That's 12 factorial divided by 9 factorial, 3 factorial. Let's see what that is. So that's 12 times 11 times 10 times 9 factorial over 9 factorial. And I'm going to write this as 3 times 2 times 1. The 9 factorials divide out, right? 3 times 2 is 6. Y'all agree that all this right here is 6? 3 factorial is 6, and that 6 reduces in the 12 2 times. So it's 2 times 11 times 10. 2 times 11 times 10 is 220. 220. So this is 220. And then if we reduce the 5 and the 220, 220 divided by 5, you get 44. And so 1 times 21 is 21, and then 44, and that is what this was. Okay, so 21 over 20 over 44 is this. All right, so that's a lot of work to get to. See how much work this is? It's a lot of work. So what I'd like for you to do is to go back and do this again without looking at it, and then if you get stuck, go back to the video, pause as many places as you can until you get to where we get the answer. All right. But on a calculator, go back and make sure you can use your calculator with this, and then just see if you can figure it out by hand as well. Okay? All right, so that'll be part one, and we're going to look at part two in a little while.